In this video, we're going to take a look at graphing linear equations by using their intercepts. We're going to take a look at a concept of slope as well. First, the intercept method of graphing. In our last video, the last example of the line that I graphed, but by using a table of values, I chose to use the intercept method then without calling it that. In this case, I've set up two work areas, one to find our x-intercept and one to find our y-intercept. As we look at the coordinate grid, I changed the color here. As we look at the coordinate grid, we label again our x-axis and our y-axis, and we'll put a scale 6, 6, negative 6, negative 6. So we're still going by ones on each of the axes. Along the x-axis, the y value is 0 because I'm not going up to a positive y value or down to a negative y value. I'm staying along this axis with a y value of 0. So the ordered pair, or the point that the line will cross this x-axis, it's going to have a y value of 0. And it will have an actual number for x when we're looking at an x-intercept. Similarly, the y-intercept will be along the y-axis, and so we're not moving left to a negative x value or right to a positive x value. We stay right along an x value of 0 along the y-axis. So the x-coordinate will be 0, and there will be an actual value for y when we're looking for a y-intercept. And so we only have two ordered pairs to substitute. 3x minus 2 times 0 minus 5 equals 0. Looking for the x-intercept, negative 2 times 0 is 0, and so we have 3x minus 5 equals 0. We'll add 5 to both sides of the equal sign to isolate the variable term of 3x. And then to isolate the variable, we will divide both sides by the coefficient of 3, leaving x equals 5/3. So 5/3, 0. We'll break each of these boxes into thirds along the x-axis. 1, 2, 3/3, 4/3, 5/3 is going to be right in here. 5/3, and 2 whole would be 6/3. So 5/3, 0 is our x-intercept. The y-intercept, we substitute 0 in for x. Three times 0 is 0, and so we have negative 2y minus 5 equals 0. We'll add 5 to both sides of the equal sign to isolate the variable term. 5 equals negative 2y, and we'll divide by negative 2, the coefficient, and y equals negative 5/2. So now along the y-axis, we're going to go from the origin down 5 halves. So we'll break up into halves. 1 half, 2 half, 3 halves, 4 halves, 5 halves, right in the middle of -2 and -3. And we'll connect these points with a straight edge. I will do my best to graph here without a straight edge. It's helpful to extend our graphs all the way through the given coordinate grid. Using our straight edge. This is listed as example 3, but really it's the second one. You didn't miss an example. This is number 2. Looking for the x-intercept, again we will substitute 0 in for y, and to find a y-intercept we'll substitute 0 in for x. And it's important maybe for you to write that every time you get started. To keep yourself organized. Again, we'll set up our scale, and we've labeled the x and y axis. We've set up saying put 0 in for x, and so for y to find an x-intercept. So 3x minus 5 times 0 equals -15. -5 times 0 is 0. So 3x equals -15. Divide by the coefficient 3. X equals -5. This graph is going to work out a little nicer than the last. The x-intercept, -5. The y-intercept, we sub 0 in for x. Three times 0 is 0. So we have -5y equal to -15. Divide both sides of the equal sign by -5. Y equals +3. And using a straight edge now, you can connect both of these points. And it's helpful to extend completely through the given set of axes. Every line, every diagonal line anyway, has slope. And in this next portion, we're going to explore slope. The slope of a line is the degree of the slant or tilt that that line has. And we'll use the letter m in our equations and as we talk about it to represent slope. So m will represent slope. Slope can be defined several ways. The change in y divided by the change in x, or the Greek letter delta is often used in math to represent change. So delta y over delta x. Slope also can be defined as rise over run, the amount of rise up or down the graph would have over the run to the right or the left. In words, that's a vertical change over a horizontal change. If we're given 2 points, x1, y1, and x2, y2, we could use this formula, y2 minus y1 divided by x2 minus x1. Both that formula and this definition will be the most valuable to you as you work in Unit 4 and moving forward in your math career. So first, I'll give you 2 points and ask you to find the slope. This formula, y2 minus y1 over x2 minus x1, is going to be the most beneficial. y2 minus y1 over x2 minus x1. This will give us a way of calculating the vertical change and the horizontal change, or the rise and the run. To help yourself cut down on mistakes as you begin this process, it's helpful to label x1, y1, x2, y2, and then substitute those values in. y2 is negative 4 minus y1, which is 5, divided by x2, which is 4, minus x1, which is negative 1. I want to point out some things about this formula and what we've just done. Point 2, y2, x2, is stacked above each other. And point 1, x1, y1, are also stacked above each other with the y's over the x's. That will help you stay organized if you check for that. Okay, negative 4 minus 5 is negative 9, and positive 4 minus a negative 1 is the same thing as 4 plus 1, or 5. So the slope of the line containing these 2 points is negative 9/5. For the rest of these examples, you may choose to pause the video and try it on your own, and then push play to check and see if you got it correct. I find it helpful to write the formula each time, especially when I'm first getting started in learning this formula. It'll help us commit it to memory, because as we say it to ourselves, we're writing it down. It's even helpful to say it out loud. That will help your brain reinforce the memorization of this formula. Again, we'll label the points, and you may choose to label them differently. Like, this does not have to be x1. This could be point 2, and that would be x2, y2, and this would be x1, y1. The only thing that matters is that both x1 and y1 come from the same point. So as we follow this process now, substituting into the formula, y2 is 2 minus y1, 6, divided by x2, 4, minus x1, 6. 2 minus 6 is negative 4. 4 minus 6 is negative 2. Negative 4 divided by negative 2 is a positive 2 over 1, or just 2. That is the slope of this line. If you chose to label this x1, y1, and the second point x2, y2, you would have had 6 minus 2, which is positive 4, and 6 minus 4, which is positive 2, which still simplifies to a positive 2. So as long as your points are stacked above each other, y and the corresponding x, the other y and the corresponding x, you will come up with the same answer for slope every time, regardless of which one has a subscript 2 and which one has the subscript 1, representing point 2 and point 1 respectively. Example C. Slope is y2 minus y1 over x2 minus x1. We substitute. I'm going to call this point 2 and this one point 1. So x1, y1, x2, y2. Negative 2 plus 4, because I substitute a negative 4 and I'm subtracting that. Subtracting a negative is adding a positive. So negative 2 plus 4 over 3 minus 3. Negative 2 plus 4 is positive 2. 3 minus 3 is 0. 2 divided by 0 is undefined. We can't take any number, 2 for example, and break that up into 0 groups. So, or groups of 0. The slope is undefined. And in the next video, we will explore what that exactly means. Example D. We'll take this as point 1, this as point 2, and substitute. Negative 5 minus negative 5 divided by 9 minus 1. Negative times a negative becomes a positive, as it did in the previous example and a few others as well. So negative 5 plus 5 is 0, and 9 minus 1 is 8. Unlike example C, we can have 0 in the numerator. 0 can be divided by 8. We will get 0. So the slope here is 0, where in example C it was undefined, now 0. And example D, looking at a slope of 0, we will explore again in greater detail in our next video. But we'll continue slopes and intercepts on this slide. Slope-intercept form of a line is y equals mx plus b. If you remember working with linear equations in two variables, this is probably the form of the line that you are most familiar with, where m is the slope and the coordinate 0b is the y-intercept. The advantage of this is that you have the slope and the y-intercept easily identifiable, which is helpful to graph in a different method. That would be graphing using the slope-intercept form. of a line. And we'll explore that as well as we look at our next examples. Find the slope and y-intercept of each equation, and then I'm adding that we're going to graph as well. And graph the line. So y, x, we'll put our scale in, again going by 1. As I look at this equation, and we remember slope-intercept form is y equals mx plus b, where m is the slope, so I know that the slope is 3 over 1, and the y-intercept is b, or -2. The coordinate 0, -2 is what we will graph for the y-intercept. And another name for the y-intercept, or what I like to call it, is kind of our starting point. Because that point is where we'll start our graph. And from there, we will count a slope, rise of 3, positive 3, over run, a positive 1. So we count up 3. 1, 2, 3, and then we run to the right, positive 1. Again, we'll continue now from this point. Up 3, to the right 1. We could also go down 3, but that would be left 1. So if both the numerator and denominator were negative, that would also be positive, because a negative divided by a negative is a positive. So this gives us now very quickly a whole bunch of points. That we can connect with a straight edge to show this line graphed using the slope-intercept form, identifying the slope and the y-intercept. First, example B. We want to first get this equation into that slope-intercept form, y equals mx plus b. And you may remember, if you've been following along with this series of videos, that in the literal equation video, solving literal equations, we looked at an example using this form, y equals mx plus b. Here is a case, or the process that we're doing now in these next examples is applying what we learned in the solving literal equations video now for a purpose. I want to solve this equation that has two variables, therefore making it a literal equation, by for y, solve it for y. So we're going to divide every single term on every side of the equal sign by 4, which will give us y by itself, because 4 divided by 4 is 1, equals 5/4 x plus 8 divided by 4 is 2, which tells us our starting point, or b, the y-intercept, is positive 2, and the slope is 5/4. Again, rise over run. So we'll start at a y-intercept, locate the y-axis, and find that point 0, 2. And then we'll count our rise, positive 5, and run to the right 4. Whoops. Okay. Or we could also look at -5 divided by -4 as an equivalent slope. So we could count down 5, 1, 2, 3, 4, 5, and the run, -4 to the left, 1, 2, 3, 4, and there's our points, which we can connect using a straight edge Unfortunately, I have to freehand this on this program. So your line will look much better than mine as you are graphing and following along. The last example we will look at, we need to solve for y again. So the literal equation we need to convert to look like y equals mx plus b. We will subtract 4x from both sides of the equal sign. So 2y equals negative 4x plus 7. Now I chose to write the negative 4x before 7. Often students will write it afterwards. But I chose to put that first because I want the equation to look like this. Y equals mx plus b. So that the term including x comes first. It will help me find slope and y-intercept better. So this would be something that you may choose to do as well. I believe it will help greatly. Continuing to solve for y, we'll divide every term by 2. And now y is by itself because 2 divided by 2 is 1. Equals negative 4 divided by 2, or negative 2x, plus 7 divided by 2. And we can leave that as 7 halves, which we know, or could figure out, is 3.5. The directions asked us to find the y-intercept, so that is the b value, or 7 halves, and the slope, which is negative 2 over 1. So if we graph using the slope-intercept method, again, label x, y, and include our scale. Writing the scale each time, especially in a larger graph, will help you graph easier because you can find points quicker using the scale that you've written, in addition to being a clear description for somebody to read what the graph is showing. So our y-intercept, 7 halves, or about 3.5. And from 3.5 on the y-axis, we're going to count a slope rise negative 2, 1, 2, and run positive 1 to the right. Because we started in the middle of 3 and 4, when we count down 1, we're in the middle of 3 and 2. Count down on the second one, we're in between 1 and 2. And that's why we end here. We can continue counting down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, or we could count up 2 to the left 1, up 1, 2 to the left 1, which will give us this line. I did better freehanding earlier lines than this one, but you get the idea. I'd like to add one additional note for you about slope, and that is if, as we read from left to right our graph, the line falls. So if the graph falls from left to right, the slope will be negative, which is a helpful check for you to see if your math was correct. You know, this is a negative slope. Is the line falling from left to right. This helps you determine if you did count the slope correctly, rise over run. And similarly, if the graph, like the previous example, rises from left to right, the slope will be positive. In conclusion, we've looked at two different methods of graphing a linear equation in two variables. One was just using a table of values, and you are welcome to use that method every time. However, graphing with the intercepts might be better for you, to substitute 0 in for x and y to find the x and y intercepts, and graph using those 2 points. I did add a third method, which was to graph using the slope-intercept form of a line, where you will have to potentially do some algebra to get your equation to look like y equals mx plus b, where you can easily identify the starting point or y-intercept of b and your slope m to be able to graph your line. Each method has its benefits and disadvantages, and so you may choose to use several methods to graph your line. You may choose to use one, and that will be perfectly acceptable.